to perfect problem 5 for Math 251. We're asked to show essentially what the derivatives of each of these different inverse trig functions are. And kind of the trick for doing that is to use implicit differentiation. So let's see, maybe for the first one, I'll let y equal arc sine of x, and then my goal will be to find y prime. Maybe I even write that here. Let's find y prime. That's basically what this hint right here is saying. So the way to do that is, well, we don't know the derivative of arc sine of x is what we're trying to show. So I can't just take the derivative of both sides of the equation. But what I could do is take the sine of both sides of the equation and then take the derivative of both sides of the equation. The derivative of sine of y is cosine of y times y prime. That's chain rule going on here. The outside function is sine of something. The inside function is the y. Derivative of x is just 1. So to solve for y prime, I divide both sides by cosine of y and get that y prime equals 1 over cosine of y, which is true, but you don't want to define the derivative of y in terms of y. So instead of writing cosine of y, I'll say it's the cosine of arc sine of x, because up here I said y is arc sine of x. And this is good. This is a perfectly fine derivative, but it's not what we have written up here. So I'll have to do a little bit of work to simplify this to get it to look like this. So maybe I'll even write that over here. Let's simplify cosine of arc sine of x. And the way we'll do that is let's let t be equal to arc sine of x. Because if t equals arc sine of x, then the sine of t is equal to x, which I'm going to write as x over 1. And if the sine of t equals x over 1, that means I have this picture right here. It means that if I'm calling this angle t, using SOHCAHTOA, the opposite side over the hypotenuse has to have a ratio of x over 1. And if I know two sides of a right triangle, I can figure out the third side. I'll give this a name, maybe a. I know that a squared plus x squared has to equal 1 squared. So what that tells me is that a squared is 1 minus x squared. In other words, a is plus or minus the square root of 1 minus x squared. But since it's a length, I can just make it the positive square root of 1 minus x squared. So a equals the square root of 1 minus x squared. And now what I can do is I can go back here, and my original goal was to simplify the cosine of arc sine of x. But arc sine of x is just this thing I'm calling t. So really, to simplify the cosine of arc sine of x, I can say it's just the cosine of t. Because I can figure out the cosine of t from coming down here and looking at this little triangle, this picture. Cosine is the adjacent side over the hypotenuse. So the cosine of t is the square root of 1 minus x squared divided by 1. So what I have is cosine of arc sine of x is just the square root of 1 minus x squared. So what I get over here, maybe one line lower, is that y prime is 1 over, instead of writing cosine of arc sine of x, I'm going to say cosine of arc sine of x is just this thing. My answer is 1 over the square root of 1 minus x squared. Now repeat that 2 more times. Might have to start writing a little bit smaller. For the second one, we figure out arctangent of x. So for arctangent of x, I wonder if... well, whatever. The derivative of arctangent of x, I'll start by saying y equals arctangent of x. And then I'll take the tangent of both sides of the equation to get tangent of y equals x. And then the derivative of both sides of the equation. The derivative of tangent of y equals secant squared of y times y prime. And the derivative of x is just 1. I know up here I said use only the derivatives of sine and cosine. I want to change that. Use only the derivatives of trig functions. You don't have to break tangent up into sine over cosine and use the quotient rule. It's easier to do it this way. Okay, so you get here and you solve for y prime. You get y prime equals 1 over secant squared of y, which you can write as secant of y squared if you want. And the reason I read it like that is I think it'll make it a little bit easier to find our answer. I don't want to leave my answer as secant of y, though, because I know y is arctangent of x. So what I'm going to say is my answer is 1 over secant of arctangent of x squared. And then over here, I'm going to simplify the secant of the arctangent of x. And the way I'm going to do that is the same thing. I'm going to let t be equal to the arctangent of x. Because if I do that, really, the secant of arctangent of x is just the secant of t. If t equals the arctangent of x, then the tangent of t is equal to x, which I'll write as x over 1, so that I can come over here and draw this triangle. If I throw t over here, I know that tangent is opposite over adjacent. And so I don't know the length of this side right here, h, but I could figure it out because this squared plus this squared equals this squared. So the square root of this guy is equal to 1 squared plus x squared. So then I come over here and I say, well, the thing I'm trying to simplify is just the secant of t. The secant is 1 over the cosine. The cosine is adjacent over hypotenuse. It's this over this. So 1 over the cosine would be this over this. Wait a minute. I drew my picture wrong. Damn. Tangent of t equals x over 1. Tangent is opposite over adjacent. So the opposite side should be the x and the adjacent should be the 1. Turns out that doesn't change what I found here. This is still 1 plus x squared because this squared plus this squared has to equal this squared. But that'll change over here when I'm trying to figure out the secant of t. I say secant is 1 over cosine. Cosine is adjacent over hypotenuse. So the cosine is 1 over this thing. So the secant is just this thing, the square root of 1 plus x squared. So then what I can do is I can come over here and say, well, the secant of the arctangent of x, this thing inside these parentheses, is just this guy. So I get 1 divided by the square root of 1 plus x squared for this squared right here. The squared and the square root cancel out, and what I get for my final answer is 1 over 1 plus x squared, which is what it was supposed to be if you go and look up here. All right, one more time. I want to figure out, we want to let y equal, which one am I doing now? Arcsecant. Okay. And the method we use will be the same as we've been using. Do I have more room anywhere? Not really. All right, y equals arcsecant of x. If y equals arcsecant of x, then the secant of y equals x. Maybe I'll write this over here. So if I take the derivative of both sides of this equation, the derivative of secant of y is secant of y times tangent of y. That's the outside function. I have to multiply that by the derivative of the inside function, which is y prime. And the derivative of x is just 1, so what I get is that y prime is equal to 1 divided by secant of y times tangent of y. But I shouldn't leave y's in my derivative for y if I can help it. So instead of writing secant of y, I'm going to say that it's the secant of, well, y is just arcsecant. So the secant of arcsecant of x times the tangent of, instead of writing tangent of y, I'm going to write tangent of arcsecant of x. Then I'm going to try to simplify this guy. When I simplify this guy, 2 things to notice. The secant of the arcsecant of x is just x. No need to draw any triangles or anything. Those are inverse functions. They just cancel out. What I need to figure out is what is the tangent of arcsecant of x. So I'll do that over here. Let's simplify tangent of arcsecant of x. Well, the way I'll do that is I'm going to let t be equal to arcsecant of x, Because if I do that, then I know that the secant of t is equal to x over 1. So my triangle, which I'll try to squeeze in here, if I put a t here, let's see, secant is 1 over cosine. Cosine is adjacent over hypotenuse. So the secant is adjacent over hypotenuse. So the secant is hypotenuse over adjacent. In other words, this is x and this is 1. And if this is x and this is 1, I can solve for this guy. What it's going to end up being is the square root of x squared minus 1. If you solve for this side using a squared plus b squared equals c squared, you get this triangle right here. Then you can use this triangle because you can say, wait, simplifying the tangent of arcsecant of x is just t. So all I got to figure out is what is the tangent of t. And to figure out the tangent of t, come down here and look at this picture and say tangent is opposite over adjacent. So the tangent is just the square root of x squared minus 1. So down here, when I was supposed to write the tangent of the arcsecant of x just equals the square root of x squared minus 1. And hopefully if I did everything right, I'd get exactly what's written up here. Sure enough. So what I've done is I've derived these 3 inverse trig derivatives. I don't recommend deriving these every time. I kind of feel like if you can do them one time, then you can just have these written down somewhere and use them as much as you want. So I'll end this video there.